Now the last blueprint class that I left to the very end is this BP_MAS_SpawnManager with the parent class. As you can see, in the BP version there is almost nothing. The only important part is this blueprint native event when I'm switching on the string to return enum value back to the C++ code. Whenever you add levels, make sure you modify the enum and modify this blueprint native event. As you can see, the AMSSpawnManager is just made from uObject, trying to keep it on the minimum. All the code is just to handle the respawning. It's all in the one place. Here we can see that blueprint native event that I just showcased. There is a bunch of other functions, but really the main meat is this process spawn data. This is triggered, as you remember, from the game mode. Basically a place where we know that all the actors have been already loaded. That means, especially for a single player, this is a very sweet spot. We add that 1 second delay that I already commented with the code design to wait for the MAS inventory widget to initialize, and then we call that whenever we travel to new level or we start a new level. So as you can see, it's a massive function, but I'm just gonna try to run some key points on what's happening when this code is triggered. We basically update the name of the level, then we set the variables, clear and shrink whatever we need to. We are using kind of view property stuff, so we avoid garbage collection, as this function might run for some time, but we will measure it exactly once I explain it. So now we store a lot of spawn data in this struct. If we look on this struct, it's quite a big struct with only 2 items exposed for a user to set up. Everything else is runtime. This is the minimum that we need to achieve all the functionality within the code. To make this more efficient, because we will be comparing location against every actor in the level of the MAS actor. That's down here. We will start iterating for the MAS actor. So we will have to compare a location against every actor in the level. The iteration can reach quite a high numbers with the nested for loops. So for example, the first actor will only compare the location against 1 actor, but once you have 1,000 actors, you have to compare the location against the 1,000 actors. If you have 10,000 actors, then the last cycle you are comparing against 10,000 actor. And of course, from program design structure, it's kind of, oh, why would you do this? Why would you design a spawn system like that? Well, it is designed like that because it suits my needs. I'm not planning to have 100 kilometers by 100 kilometers levels, and I use a lot of small levels. For example, when you enter the building, or you enter the cave, or you enter a train, I will just load a new level. I know I'm not gonna have insane amounts of actors, and it's extremely convenient way. If we look on the level design, we don't need to really think about it too much. All we do, we disable physics and we drag it into an exact location in the level. So for example, this would be another cliff, this would be another rock, bigger rock, whatever the design is, and you never have to worry about creating some billboards, or then you can't see the scale, you can't see the rotation. Like this, you exactly know that this is the mineral in the level that you want to be mined, and you don't need to worry about it. It's just drag and drop. Designed it with a drag and drop, and the code will take care for the rest. However, there is a penalty, and I was kind of really worried, and I will demonstrate it shortly. It was kind of funny because when I tried to measure the actual time of this nested for loop and the entire calculation, it was less than a frame, and I had to use like double precision variables to even measure this time, and it's significant from kind of programming point of view, but it's totally insignificant for me from a designer's point of view, of level designer, whether my level is going to load 0.02 second more, but it saves me tons of hassle. Well, I'm happy to sign for it. So you have to make your own educated decision whether this is something interesting for you or not. But I will continue to explain how I'm optimizing it here. I will extract this location from the struct, because when I'm gonna be running this nested for loop, I don't want to be looping through all the big struct data. If I'm testing, I created a level that this can be. You see, I can't use the low precision what you would normally use, get the game time thing. I have to use actual Windows F platform time to get high precision time to even be able to measure how long this code will take. So then we start the iteration. There is some debug stuff. We will assign the correct tags in case some monkey messed it up in your team. So that should all run. I will come back to this once I explain the concept and you understand it, because this is kind of additional complication which I will explain later on. We start the nested for loop within that iteration of the MAS actor, and we are only really comparing the location, and we don't want to compare the vector, because vector consists of 3 floats. So we are running kind of efficiency check, and if any of these float values are more than our location tolerance, and this is a very important float value that you will calculate, because finally in the final check we are using distance squared with that value. And I can tell you, when you are in the editor, initially I had it on 10, and for example in this box issue I would start and restart. Okay, so now if we would look on this box, if I would leave it on 10, then this kind of distance, it would start overlapping, it would start affecting the nested for loop, and it would create you a lot of errors. But if we leave that tolerance on float value 3, then this distance is not an issue. And there is also in an output log, when you run the code, because I ran into that issue, at the end of the cycle there is kind of invalid keys removed in case we would have corrupted data. Then we check for the inventory data map 9 and keys or items destroyed. So basically we can't see it right now, but there is a lot of debugging stuff that would highlight this kind of issues. If they are too close and we would run into errors, it would start popping information within this output log. So as long as you learn what the output log should look, you should be able to spot if you mess it up. My suggestion is don't put stuff too close to each other. Use this as a guidance distance and don't change the value, and then you will never run into that kind of problem. So that is an important variable. So now we compare it. If we find it that yes, this is the match we already have here in the MAS save game within this data map for the level, that will be either this or whatever, how many levels you have, this will actively be linked by reference to any of these data. Once we confirm that yes, we already in this level, we issued an ID, an f-string, unique f-string to that actor, well, then we assign the same kind of ID back to it. And if not, then we generate new unique ID to it, which we do just simply by we run some checks and then we make a new GUID. Yeah. So then we check, yeah, with all the actors everywhere we don't have such ID, and then yes, we can assign it. Now we update whatever we need to update for the spawn data, because remember and don't confuse this, we have a spawn data within the MAS save game, and then also within MAS actor we have kind of a variable that is MAS spawn data. So make sure when you call this, you understand you are just really getting copy, and whatever you change here is not gonna reflect to the changes that you need to store permanently in here. So just bear that somewhere in the back of your mind if you start modifying a code. Like, don't run into that trap that you think, oh, I have this and it's somehow linked. Well, it's not. It's this variable within the MAS actor is the same thing as if you would in the blueprints drag a copy, and it serves for its purpose. But if you really want to store it, or let's say before you store it into MAS save game data and you would lose electricity or whatever happens, boom, that data is gone. So I kind of tried to find a really good system that should handle all these electricity blackouts, and also that's why I loop absolutely everything in this function. This is like the engine of the entire system designed. But once it does its things, it shrinks and empties all these arrays that we have been using, and then it starts respawn check timer. Basically, it's a looping timer every 5 seconds, and what it does, it runs this function respawn check. It was kind of interesting that you couldn't keep it as an array of actors because the rubbish collection would mess it up. We kind of have to see it. You see, it's here, respawn actors array in the MAS save game. So the only way to keep it, that's the way to keep it. So we are really just keeping array of strings. If you look in the battery or mineral or whatever, and you look in the begin play, then we are running this set spawn class. So you don't have to touch it, it's all there. As you can see, when we click on it, it's gonna save it in the corresponding data class with the pickup. So it's not in this spawn data. This spawn data is generic one, like it's held in the MAS actor. But then every child of this MAS actor, like a battery or a cartridge or a mineral, will have its own data system. So for example, this will be FMAS battery data. And within that, we have that spawn class. So we can always find our way to spawn it. The spawning, I thought most sense it will make in the game instance, custom game instance class. Let me rather scroll through it. So there will be spawn battery, spawn cartridge, spawn mineral, and that will return us. And as you can see in here, we are recycling the function in many different scenarios. So sometimes we are using it spawning something that needs to generate ID. Sometimes we already know the ID. That's why, you know, I also filled in these values so you don't have to bother filling in all the params if not needed in certain occasions. So this is roughly how this spawn manager looks. Of course, it was hard work to get it to the stage as it is, so don't expect me to explain it everything on the video. I already think I have showed a lot to anyone who is just interested to replicate it without supporting me and buying this plugin. But now I want to highlight additional kind of functionality. When is this system to be used? Well, when we deal with something like a mineral, that's a perfect case when this system is absolutely fantastic. We will just drag and drop it and we harvest it and we get a pop-up in the widget, and that's it. Now here in the widget, let's say when we pick up a battery, and we pick up a cartridge, and let's say we pick up some more stuff. Okay. So now this is all having own data. Yeah? We have to keep a track of how much battery we have, how much fuel in the cartridge we have. We don't have that kind of issue in the inventory when you pick up a mineral, because all you would have it somehow like, oh, I pick up a scrap metal, oh, I pick up electrical parts, I picked up some minerals, and later all you need to know, to produce such and such item I need this and this and that. If you think that you would like to use an item with this kind of system, that you don't spawn it in a traditional way, but you just use it as a drag and drop. Let's have a look, for example, on this battery. And I have added here to respawn. If we go on the settings, and you see, if we go to spawn data, I wanted respawn, and I say I wanted to respawn in 10 seconds. If we start play, numpad 1, exit again. Okay, so now you would think that this battery is going to respawn, but it won't, because this system cannot handle like same items that needs to keep a track of data, like for example battery or cartridge, because these are now inventory items. The game is not going to know if you have 3 items with the same location. How do you know which one is which? So it's impossible to know. It's not an ideal situation, or there is really no good reason why would you spawn battery or cartridge in this way, because you are creating extra computing time. So normally the thing to understand is I would recommend you to spawn batteries or cartridges in a traditional way, that you have a box that just handles, okay, there should be so many or there should be none. For whatever reason, if you ever come in your design structure to a situation that you want to use a spawn location and you have inventory item that needs to keep track of data, in that case I already designed this system and I'm already here testing it on the battery and cartridge. So it's no problem if you leave it like it is, because it's only few cartridges and few batteries, but there will be another kind of project coming where I will have a machine that will just, you know, spawn the new cartridges or take old cartridges in and fills them up, stuff like that. But it's gonna work on totally different system. I have also another plugin that again handles totally different spawn system, also with a similar idea of keeping the data in the save game and kind of designed for a long spawning, like long construction time. So let's say you play another day or you play another 40 minutes of game time, you could even take a Windows time, whatever, this F platform time, you incorporate that. But the idea here is that I'm simulating this functionality. Let's say if you ask and imagine, well, how could you use the location and the item that needs to keep, so there is a failsafe, yeah. If I drop this now, this is gonna become a separate item, and by default in the code it's always set not to respawn, because otherwise this could be really abused by the players. They would just come to this pickup location, then will respawn, then they would drop it, and then again once this and that would respawn. So that wouldn't make a sense. I highlighted that in green comments, but let's see what happens now. So we exit the game and we come to the level, and now there is a battery on the floor and there is a battery in the box. And if I pick up this battery in the box and I exit and I start again, there will be battery on the floor, but there will be no more battery in the box, because yes, the system can handle that an inventory item was dropped. We generate a new virtual ID with location, and here we are back to square one, that no, this location, despite that we said should respawn in next 10 seconds, is not gonna do it, because if we would do it, we would run into problems during a next level load. I know it's a lot to take in and most likely you don't have a clue what I'm talking about, but one day if you try to design something similar, it's all gonna click on, or just watch the video again. And if it totally makes no sense, then don't worry about it. It took me a long time to kind of design it. I changed the code 20 times to reach the stage of the code as it is.